All right, so here we are again. We're supposed to use the graphing strategy like we've been doing. And so let's get back to doing what we had to do. So first off, we have to think about our domain. Okay, so what's our domain going to be here? Well, basically, it's going to be all real numbers except for what? Well, we can't have a zero here. So it's going to be all real except x cannot equal a zero, because if it does, we divide by zero. Now, what can we do to figure out where we have an intercept? Well, let's set 4x plus 3 equal to 0. So that gives us x is equal to what? A negative 3/4. And that's going to be what? An x-intercept. Okay. Now, here we have a power of 1. Here we have a power of 2. So when m is less than n, we get y equals 0 is a horizontal asymptote. And again, this is stuff from chapter 9. So if you forget about what we have here, then that's maybe something you need to go look at. So we have horizontal asymptote. Because it can't be 0, we have x is equal to 0 is a vertical asymptote. Okay. All right, so now are there going to be any y-intercepts? Well, if we have x equals 0 as a vertical asymptote, there's going to be no y-intercepts. So that's going to be kind of a key thing there. All right, so I think that's all we can get in part 1. So part 2 now says find the first derivative. Okay. Well, we'll take the bottom, which is x squared, times the derivative of the top, which is 4, minus the top, which is 4x plus 3, and then times the derivative of the bottom, which is going to be what? A 2x, and then all over, and then it's going to be x squared squared. All right, so that's going to be what? 4x squared, and that's going to be 8x squared. It's going to be negative, so minus 8x squared. That's going to be 6x minus, so it's going to be minus 6x. All right, and that's all still going to be over, and that's x to the fourth. And simplifying, we have a minus 8 plus 4, so it's going to be a minus 4x squared minus 6x all over x to the fourth. All right. Let's go one step further. Let's factor out a negative 2x, and then that leaves us with what? That leaves us with 2x plus 3, and then that's x to the fourth. All right, so what do we have? Well, if we want to look for our partition numbers, we set each of these equal to 0. So 2x minus 2x equals 0, so that's going to give us a partition number of x is equal to 0. If we set that equal to 0, we get what? Negative 3 halves. All right. And here, this one also gives us 0, and that one says basically x cannot equal 0. So that one means for critical numbers, then x is equal to minus 3 halves is going to be the only one. Now, we're going to have a partition number of 0, but the only one it could actually equal is that. So if we draw that on our graph now, we have what? 0 minus 3 halves. Now, minus 3 halves, that one, wait, at 0 rather, is the no derivative. At minus 3 halves, that's going to be the 0. It can be a 0. So now we need to look over here. So maybe let's go to minus 2. In between here, maybe let's go to maybe a minus 1. And here, let's go to a positive 1. And again, this is the first derivative. All right, so plugging in negative 2, so that's going to give us a 4. And then we'll have a minus 4 plus 3, that's going to be a negative. And so it looks like we're going to have negatives here. Okay. If we plug in a negative 1, so that's going to be 3 minus 2 is going to be 1. That's going to be a plus 2, and that's going to be a positive. So that's going to be positives in here. Well, going here to here, from negative, it's going down for a slope, then it's going to go up. So that has to be a min. Okay. Now, plugging in a 1, so that's going to be 3 plus 2 is 5 times a negative 2, so that's going to be negative over positive, and so that's going to be negatives out here. So we have what we have here. This is decreasing, this is increasing, and this is decreasing again. Okay, so negatives in the first derivative are decreasing, positives are increasing, and negatives are decreasing. All right, so we could write all that out. We could say it's increasing from where? Negative 3/2 to 0. And it's decreasing from where? Negative infinity up to 3/2 and from 0 to positive infinity. Okay. Now we said we had a minimum here, and so we have a local minima at, and we have it at what? Well, it's going to be a negative 3/2. And if we plug that into the calculator, what do we get there? Uh, All right, looks like a negative 1 1/3. So let's just call that negative 1.33, just to make it so it's easy to graph. It's probably put 1.3 and it would be even beyond what I can graph. All right, so that I think is everything we need for here. Now let's go to the second derivative. So f double prime of x. All right, so let's go back maybe to this piece. That one was made for mostly getting our critical and partition numbers. So let's go here. So we'll take our bottom, which is x to the fourth, times. Now we'll take the derivative of the top, so it's going to be what? Minus 8x. And then it's going to be minus 6 minus, and then the top, which is minus 4x squared minus 6x times the derivative of the bottom, so it's going to be a 4x cubed all over x to the fourth squared. All right, so now let's get that all sorted out. So that's going to be what? That's going to be a minus 8x to the fifth minus, and then 6x to the fourth. And then what do we have? Minus the minus is going to be plus, and 4 times 4 is 16x to the fifth. And then we have, again, it's going to be minus minus, so it's going to be plus, and that's going to be 24x to the fourth. And then that's all over x to the eighth. Now, what do we have? 16 minus 8, so that's going to be what? 8x to the fifth. And then we have 24 minus 6, so that's going to be 18x to the fourth, all over x to the eighth. All right, so now, once again, I think I'll factor. And what can I factor out? It looks like a 2x to the fourth times what? A 4x, and then plus 9, all over x to the eighth. All right, so let's see here. That's going to give me partition numbers of what? We're going to have 0 and a negative 9/4. And we have critical number here. We can't have the 0, so the critical number can only be what? The negative 9/4. Okay. And so now let's draw a sign chart for that. So we do that, we have what? Our 0 and negative 9/4. So that's going to, let's just go way out here, -5. Here we could do what? That's going to be -1. Here we could do 1. And that 0, that's in D because we can't have 0 in the denominator. That could be a 0. All right, so if we plug in a -5, now this is f double prime. Now let's simplify this for doing this piece. So if we do that, uh, that cancels that. We have 4. And so let's see if that makes it any easier. If we plug in a -5, so it's going to be -20 plus that is going to be negative. And so that's going to be a negative on this side over here. So that's negatives. Now, if we plug in a -1, that's going to be -4. That's going to be positive, positive, positive. So these are going to be positive here. And if we plug in a 1, then everything's positive. So those are going to be positive over here. Now, because that's a 0, this is an inflection point. Okay. And what else do we know? Okay, well, this is concave what? Well, this is concave down at this point. This is concave up, and this is concave up. Okay, so we'll say concave out here. So we have down, up, up. What else do we know? Basically everything we know. So if we're going to write that out, we have concave up at what point? Well, from 0, oh wait, -9 fourths, I should say. Okay, well, let's do 0 to infinity and uh, back up. Let's erase it. I guess that's okay. 0 to infinity, and then we'll put our what negative. Oh, our negative. Where's my pen? There it is. -9 fourths and to 0. Okay, and then it's gonna be concave down from where? Negative infinity up until the -9 fourths. Okay. And one other thing is we have that inflection point. I don't know, might be able to write it here, inflection point. And that's going to be at what? -9 fourths, comma. And if we plugged it into our calculator, we get, looks like about a -1.19, probably -1.2, still too much I can't get on my calculator or my drawing, but that should be good there. All right, so I think that should be everything. So let's see if we can draw this up here into some semblance of what it's supposed to look like. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. Hopefully we don't need any fours higher. All right. So let's draw some stuff here. So let's get our asymptotes. We have a horizontal asymptote and a vertical asymptote. So right on that line and right down there. And again, can't draw straight there even. All right, so now we have that. So now let's draw in some points and stuff that we know. All right, what do we know? Well, we know that inflection point is -9 fourths, -1.9. All right, so -9 fourths and then -1.9. So somewhere maybe here. We also have, what do we have? -3/2. Where do we have all our points at? Let's see. Oh, we have the local minimum. We had that -1.5 and -1.3. So that was the lowest point. So that was a little bit lower than this one. And so then we also, let's see, if we had -3 fourths 0, so that would be another one. Okay. Now we said it was concave up okay, from -9 fourths to 0. So -9 fourths to 0 is going to be concave up. So from here, let me draw. From here up, it's going to look something like that. But then from -infinity to -9 fourths, it's going to be concave down. So now we have a point of inflection here. And so now we're going to kind of go something like that. Now it's not going to be that extreme, but we're going to have that's our point of inflection here. All right. Now what else do we have? Now that gives us that piece, but now we don't know what's over on the right side. So now let's plot some points. X, Y. Let's say we have at 1, what do we have? 1 is going to be 4, 7 over 1. So that's going to be way up high. So it's going to be a high number. So we won't worry about that one. Let's go to 2. Hopefully we'll get down into our chart. 2 is going to be 8, 9, 10, 11 over. Okay, so it's going to be 11 fourths. So 11 fourths. This one we had 7. So, okay, so that's going to be, oh, that's going to be about here. This one's going to up. And then if we did a 3, that's going to be 12, 13, 14, 15 divided by 9. And so that's going to be a little less than that. So somewhere here. So looks like it's going to do something like that. Okay. And so again, rough sketch, but all this other stuff is the calculus we needed to get to that point where we could do it. Again, could we plug that in our calculator and get it graphed? Yeah, we could. But the whole key to this is using the different pieces of calculus to get to that point. All right, so let's stop there and we'll come back for more.